Bismillahirrahmanirrahim. The t-test. Normal distribution test of significance can only be used when sigma is known exactly, or at least is based on a sample size greater than 13. If this is not the case, we must use sample standard deviation S instead of sigma, and T instead of U in normal distribution. This is called T distribution or T student distribution. Example for t-test, to test the difference between the means of two samples from a single population. If two samples of N1 and N2 items are taken at random from a single population, we can calculate TAE by using this equation. Where S is the standard deviation of samples is equal we can compare this value of TE with degree of freedom equal N1 plus N2 minus 2 with table values to obtain the fractional probability that the results could have been occurred by chance. This is an example. Suppose we have the following results. The standard deviation of data. Then TAE is equal the result of this equation is 2.51. From T table you can download of internet t-table for degree of freedom 12, because number of sample 1 is 6 plus 8 minus 2 is 12. In the t-table, that show the probability percent level, the table t-table is based on degree of freedom. Degree of freedom, for degree of freedom 12 and 2 tail test the probability, and for one tail the number of percent of probability 10%, in 1 is 5. 5 is 2.5 to 1, 1.5, and 0.1 is 0.5. The number of t is for probability level of 10 in 2 tail test is 1.78, 2.18, 2.68, 3.5, and 4.32. Alpha for this is confidential 19%, and alpha is 0.5 in this column. If our alternative hypothesis had been x1 bar is not equal x bar 2, x bar 1 may be greater or less than x2. Therefore, we would use a two-tail test. Because x1 may be greater than x2 or less than x2. This is two-tail test. Where TAE in t-table is equal 2.51. corresponds to 5% is greater than 2 alpha greater than 2%. The two means are significantly different. If we had stated our alternative hypothesis as x bar 1 is less than x bar 2, the one-tailed test shows that the difference between means is significantly less than 2.5% confidence limit. Therefore, alpha is between 1% and 2.5%. This equation for finding TE was obtained on the assumption that S1 is equal S2. We can use of S and can be used whenever the ratio of the variance is not significant by F-test. For the equivalent of S1 and S2, we can use F-test. F-test. If there is non-homogeneity, S1 is not equal S2, the t-test cannot be applied, but we can use one of these two tests, tangente theta test or well test. You can search about well test for determine non-homogeneity variances and F-test. This is an example is x1 bar significantly greater than x2 on the following data. The variance of sample 1 is 2.25 with degree of freedom is equal number of experiment minus 1. This is 11. And for x bar 2, degree of freedom 1, degree of freedom 2 is 10. For determine that these two variances are significantly different, we might to to calculate from f-test. F is equal the greatest variance of the sample S2 this is greater than this, therefore F is 12.1 divided by 2.25, that is equal 5.38. From F table and single side, because we want to determine that is S2 greater than S1? Greater than. Therefore, only greater than. Therefore, that is one side test. For F test depends to 2 degree of freedom of sample 2 and sample 1. For degree of freedom 10 and 11. From F test, the alpha of the table is 0.005. That means with 99.5% S1 and S2 are significantly, or there is significantly difference between S1 and S2, S1 and S2. This means that variances are significantly different. Therefore, t-test cannot be used for determine the significantly difference between these two average. Therefore, we might use from tangent theta test or well test. If there was no significantly difference between S1 and S2 from F-test, we can use of t-test for determine the significantly difference between these two means. Goodbye.